Hi everyone, today we'll be looking at the October 2020 statistics paper. Question 1, it's a Venn diagram. We've got the probabilities associated with 4 events A, B, C, and D. And we are being asked in part A to write down any pair of mutually exclusive events. Well, we know that mutually exclusive events are those that have nothing in common. So looking on the Venn diagram, we could pick D and B, or D and C, or even A and C. All of these are correct answers. So in part A, it could be A and C, or D and B, or D and C. Now, given that the probability of B is 0.4, which means that all of this is 0.4, I need to find the value of P. Well, obviously, I will add these three probabilities and set them equal to 0.4. So 0.24 plus 0.07 plus P is 0.4, which leads to 0.31 plus P being 0.4. So P is 0.09. And it's actually a great idea to keep updating the Venn diagram with all the information that comes to light. That's the 0.09. And then, given also that A and B are independent, find the value of Q. Well, if A and B are independent, it means that the product of their probabilities is the probability of the intersection. So, probability of A intersection B is the probability of A times the probability of B. Now, the A intersection B is the common region, is the 0.24. So I'm just going to say that 0.24. The probability of A, I'm adding all the regions, the 0.24, the 0.16, and the Q. And the probability of B, we know from the previous part that it's a 0.4. I will divide and get 0.6 is 0.4 plus Q. So Q is 0.2. And once more, I will update the situation here. That's the 0.2. Given further that the probability of B dash given C is 0.64, find R and S. Well, probability of B dash given C means that we are surely in C. So we are certainly here or here. The probability I'm outside of B, the B dash, that's what it means. I'm outside of B. So the probability I'm here is 0.64. So I would say that R over R plus P is 0.64. So that's a DI. R over R plus P is 0.64. We have found P to be 0.09. So R over R plus 0.09 is 0.64, which we will cross multiply. R is 0.64R plus 0.0576, which leads to 0.36R is 0.0576. And if I divide by 0.36, I'll be getting an answer of 0.16. That's the value of R. So once more, we go back to the Venn diagram, and we know that R is 0.16. Now, to find the value of S, we know that the sum of the probabilities should be 1. So I will add everything up and set it equal to 1. So I'll be saying that 0.2 plus 0.16 plus 0.24 plus 0.07 plus 0.09 plus 0.16 plus S is 1. So we end up with S being 0.08. In question 2, it's a random sample of 15 days taken from the large dataset for Perth in June and July 1987. This is the scatter diagram for two of the variables for these 15 days. we need to describe the correlation, and obviously what we see here is negative correlation. As one variable increases, the other decreases. That's all we need to say though, negative correlation. And then in B, being told that the variable on the x-axis is daily mean temperature, using our knowledge of the large data set, we need to suggest which variable is on the y-axis and the units in which this is measured. So we've got daily mean temperature here, and we've got something that decreases with increasing temperature. So the greater the temperature, the less this becomes. So we could say that this could be the daily total rainfall. The more the temperature, the less the rainfall. So daily total rainfall, and this is measured in millimeters. Another thing you could mention would be pressure, and we know that pressure is measured in hectopascals. Staff believes that there's a correlation between daily total sunshine and daily maximum relative humidity at Heathrow. He calculates the product moment correlation coefficient for a random sample of 30 days, obtaining a value of minus 0.377 for R. We need to carry out the hypothesis test at the 5% level, and we need to state clearly hypothesis and critical values. So I will start by writing out that my null hypothesis says that rho is 0, and my alternative that rho is less than 0. Be careful here, if you say R instead of rho, you will be penalized. From the data set, we obtained R to be minus 0.377 with a sample of size 30. From the table of critical values, we obtained that the critical value at the 5% level is minus 0.3061. You might be wondering where the negative sign is coming from. Well, the table is actually giving you only positive values. However, we turn it negative because we're looking for a change towards the left side of the distribution, towards the negatives. And then it's helpful if we draw something like this. The minus 0.3061 is here. It's the critical value which defines the critical region, and what we have just seen, the minus 0.377 lies within the critical region. So minus 0.377 is less than minus 0.3061, which means this is significant. We reject the H naught, and we need a conclusion in context. So we say evidence of a negative correlation between sunshine and humidity. Your conclusion should always be in context, otherwise you will be penalized. And then on a random day at Heathrow, the daily maximum relative humidity was 97%. Comment on the number of hours of sunshine you would expect on that day, giving a reason for your answer. So we have a particularly high value for humidity. So what we need to say, just to join everything together, is that humidity is high. So we've got high humidity and negative correlation, as we have found in part C, and negative correlation with sunshine. Hence, we expect lower than average hours of sunshine. So all we're saying here is that because we've got a particularly high value for humidity, then And this negative correlation, it means the greater the humidity, the less the sunshine. So we've got lower than average hours of sunshine. We have to give a reason here just to justify everything together. In question 3, we've got 27 people timed when completing a puzzle. X is the time taken, and this is the box plot summarizing the findings. Find the range of the times. Well, obviously it's the maximum, take away the minimum. So the range will be 68 minus 7, which is 61. In part B, find the interquartile range. This is Q3 here, and this is Q1. So it's gonna be 25 minus 14. So the interquartile range is 25 minus 14, which is 11. And then we're being given some summary statistics, the sum of the values and the sum of the squares, and we need to calculate the mean time and the standard deviation. So for the mean, we know that x bar is sigma x over n, which will be 607.5 over 27, which is 22.5 minutes. And for the standard deviation, sigma, it's sigma x squared over n minus x bar squared, or square root, which will be 17,623.25 over 27 minus 22.5 squared, square root of that, and that's 12.1 minutes. It's good to include the units of measure, and we know that the mean and the standard deviation have units of measure exactly the same as the original variable that we are looking at. Now, Taruni defines an outlier as a value more than 3 standard deviations above the mean. State how many outliers Taruni would say there are in this data set, giving a reason for your answer. So I will take the mean, 22.5. I will add 3 standard deviations. I get an answer of 58.8, and only 68 is greater than 58.8. Hence one outlier. Now remember that in a box plot, outliers are identified with crosses. This means that from above 40, we only had 2 observations, the 42 here and the 68 here. The only one which is above the threshold that Tarun is using is this one. That's why we end up with just this outlier. Adam and Beth also completed the puzzle in A and B minutes respectively, with A being greater than B. Now, when there are times, we are also taking into account the median time increases, the mean time does not change, suggest possible value for A and a possible value for B, explaining how your values satisfy the above conditions. Now, just the wording suggests a possible value for A and a possible value for B is implying that there are multiple possible answers. So let's see. The mean time does not change, which means that these 2 values average to the same mean we had before. So since the mean remains the same, we must be having that A plus B over 2 is 22.5, i.e. we have 2 values that add up to 45. And then since the median increases, they must be above the median. Then both A and B are greater than the median in order to push the median to go up. and the median was found to be 20. So we need two values that add up to 45, both of them being greater than 20, and we have A to be greater than B, so I could say A is 23 and B is 22. Obviously, I could also say 24 and 21, and I would also be suitable answers. And then part G, without carrying out any further calculations, explain why the standard deviation of all 29 times will be lower than the answer we obtained in part D. Now, this is really calling for a solid understanding of what the standard deviation is. It's the distance, the average distance between each point and the mean. Now, we suggested 23 and 22, and we know that the mean is 22.5. We have found the standard deviation to be 12.1, which means that the points were on average 12.1 units away from the mean. And we've got two new values, 23 and 22, that are really close to the mean, because the mean is 22.5. So we simply have to say that 23 and 22 are closer to the mean, which was found to be 22.5, than one standard deviation, which was 12.1. So we will now have on average points closer to the mean, and therefore the standard deviation will be smaller. Hence, the standard deviation will be smaller. Question 4. The discrete random variable D has the following probability distribution. It takes values of 10, 20, 30, 40, 50 with these probabilities. K is a constant. We need to show that K is 600 over 137. I will simply add all of these up and set them equal to 1. So in part A, we've got K over 10 plus K over 20 plus K over 30 plus K over 40 plus K over 50 equals to 1. So I get 137 K over 600 equals to 1, which means that K is 600 over 137 as required. And then we've got two observations, D1 and D2, independent observations coming out of the distribution of D. I need to find the probability that they add up to 80 and give my answer to three significant figures. So I could simply think of the different combinations that will give me a sum of 80. It could be that D1 is 30 and D2 is 50. The fact that the two observations are independent means I can multiply the probabilities. It could be the other way around. It could be D1 being 50 and D2 being 30. Or we could have that D1 is 40 and D2 is also 40. So this means I have K over 30 times K over 50 plus K over 50 times K over 30 plus K over 40 times K over 40. I will do the calculation with a value of K of 600 over 137 on the calculator. I get an answer of 705 over 18769. I've been asked to give my answer to three significant figures, so this is 0.0376. Now we've got a single observation of D made. The value is the common difference of an arithmetic sequence for which the first 4 terms are the angles in degrees of quadrilateral Q. And we need to find the exact probability that the smallest angle of Q is more than 50. So let me start with the basics here. I will be drawing a quadrilateral. So there we go. And I could say this is theta, this is theta plus d, this is theta plus 2d, and this is theta plus 3d. These are the 4 angles in this quadrilateral. They form an arithmetic sequence. We know arithmetic sequence have this property that consecutive terms have the same difference. I will add everything up, so theta plus d plus theta plus 2d plus theta plus 3d is 360, which leads to 4 theta plus 6d is 360. Now d will come out of the distribution. We know that d could be 10, 20, 30, 40, or 50. And based on this relationship here, I will be determining the corresponding values for theta. So if d is 10, theta turns out to be 75. If d is 20, it's 60. Then it's 45, 30, and 15. We were just asked to find the probability, it says, of the smallest angle, so Q being more than 50. So the smallest angle is more than 50 here and here. And the associated probability is just the probability of being equal to 10, which was k over 10, and the probability of being 20, which was k over 20. So the probability required is just the sum of these two. It's k over 10 plus k over 20, which is 90 over 137. In question 5, it's a health center claiming that the time a doctor spends with a patient can be modeled by a normal distribution with a mean of 10 and a standard deviation of 4 minutes. And we need to find the probability that the time spent is more than 15 minutes. So it's a good idea to say that x is the time. We follow a normal distribution with mean of 10 and a standard deviation of 4, so it's 4 squared. The probability of x greater than 15, I can easily extract this from the calculator, and it's 0.1056. It's a good idea to be giving answers here to 4 decimal places. Now, some patients complain that the mean time the doctor spends is more than 10 minutes. So we took a random sample of 20 patients and we got a sample mean of 11.5 minutes. And we wish to test at the 5% level where there's evidence to support this complaint. So I will start obviously by writing out my null and alternative hypothesis. So my null says that mu is 10 and my alternative that mu is greater than 10. That's the claim, the complaint. So alpha is 0.05. Now under H naught, which means that if the null hypothesis is indeed true, x bar will follow normal with a mean of 10 and a variance of 4 squared over 20. Remember, this is based on a sample. It's the sample mean, so we divide the variance by n. Now the probability of x bar be greater than 11.5, which is what we have seen, is 0.0468 from the calculator again. Notice that the direction here has been inherited from the alternative. This is less than 0.05, so I will simply say significant, reject H naught. So we need the conclusion in context, so we've got evidence to support patient's complaint. So we always end up with a conclusion in context. And now part C, we've got a health center claims that the time a dentist spends is capital T, which is normally distributed with mean of 5 and a standard deviation of 3.5. And using this model, we need to find the probability that the routine appointment will take less than 2 minutes. So we've got here in C that T follows normal 5,3.5 squared, and the probability of T being less than 2, I'm just going to use a calculator here, is 0.1957. And in II, we're being asked to calculate this probability here. The probability of T being less than 2, given that T is greater than 0, a conditional probability question here. So I always suggest that you draw a bell-shaped curve just to see exactly what's going on here. So this is my distribution here. It was centered at 5. So there it is, 5. And we know for sure that we are greater than 0. And we want to check on the probability that T is less than 2. So we know that we're greater than 0, so I will draw the line here. 0 is here. So we are certainly in here. And the question is, what's the probability we are actually less than 2? So this is conditional probability. We know for sure that we are within this region, which I'm shading here in red. So what is the probability that I'm less than 2? Well, if 2 is here, the intersection of these two regions will simply be this part here. So I will simply say that this is the probability of 0 less than T less than 2 over the probability of T being greater than 0. In the denominator, I will always be seeing what I know for sure to have happened. So this is 0.1191 over 0.9234. Of course, I'm using full accuracy in finding an answer of 0.1290. And then III hence explain why this normal distribution may not be a good model for capital T. Well, we've got the probability of T being less than 2 and the probability of being less than 2 given that T is greater than 0, and we can see that they are not in close agreement. Now, we certainly know that waiting times are positive. So I'm just going to state that waiting times are positive since the answers to I and II are not in close agreement. This normal distribution is not a good model. So all we are saying is that being a model that looks at waiting times, it shouldn't really allow for a negative waiting time. So if we took into account the fact that T is greater than 0, which we know for certain that it should be the case, these two values shouldn't differ so much. But this is almost 20% and this is 13%. That's a large difference. So we conclude that this normal distribution is not a good model. And the final part D, the dentist believes that she cannot complete a routine appointment in less than 2 minutes. And she suggests that the health center use a refined model which only includes values of capital T being greater than 2. Find the median time for a routine appointment using this new model, being your answer correct to 1 decimal place. So it's a 5-mark question. That's a lot to think about and to do here. So as always, start by drawing your bell-shaped curve just to illustrate exactly what's happening here. Now, we knew that the mean was at 5. Now the dentist is saying that there is no chance something will be, an appointment will be completed in less than 2 minutes. So we are certain, we know for sure, that all the waiting times will be here. And I would like to find the median time. Now, the median time in this restricted area here. And the median is the middle value such that half of the observations lie below and some of them, half of them lie above. So it could be somewhere here. I could call it M, such that this probability, which I'm shading in blue, which I could call P, and this probability here are both the same. Now, we have already found in CI that this part here is 0.1957. So we could simply say that 0.1957 plus P is equal to 1. So 2P is 0.8043, which means that P turns out to be 0.4021585, and that's the value we'll be using. So the probability of T being less than M is simply 0.1957 plus P, which is 0.1957 plus 0.4021 ... I'll be using full accuracy here, inverse normal on the calculator, which leads to an answer of 5.867, which is 5.9 minutes to 1 dp as the question was instructing us.